I'm Valerio Baiocchi from the La Sapienza University of Rome, Faculty of Engineering. Co-author of this work are Valerio and Martina Marmina, that will present each presentation this afternoon. And also the author is Katie Velo from the Tech University. I present this work on accuracy of different georeferencing strategy on historical maps of Rome. Yes, okay, sorry. And this is important for the historical maps of Rome, but is a matter that is very important for all the historical maps. The main goal of this work was to correct and accurately georefer two series of maps that were drawn by Istituto Geografico Militare, that is still the national agency for cartography and geodesy in Italy. These two series of maps were drawn at 1 to 5,000 scale, and they represent the city of Rome and a little part of the surrounding. These maps are very important because the most part of the development of the city occurred just after this date. In fact, these maps were asked from the municipality of Rome to the Istituto Geografico Militare to project the development of the city. So it's important because there is a representation of the city and also a representation of the ground. It's very useful because we can extract a digital elevation model of the morphology of the city before the big urbanization. The steps of this georeferentiation are, at first, the study of geodetic datum transformation between the ancient datum, geodetic datum, and the modern one. Then we studied this part and we presented it in another paper, but we will see this part very quickly. Then, what we present here is the study of the different georeferencing algorithm to georeference and rectify the raster file. Because it's important, I distinguish these two operations because some software made only one transformation, or the two in different moments, or the two together. One thing is georeference a map, a raster map, so giving to the map the coordinates in the grid on the geodetic system that you want to use. Another thing is change the geometry of the file. Some software make only one of these operations, for example, map info, only georeference the file. It don't change in every way the shape of the raster file. ArcGIS make these two operations into different moments. If you want, you can only georeference. If you want, you can georeference and after rectify. Other software, like for example, QGIS, in this moment, make the two operations together. But we have to understand what are the effect of the different algorithms on the map. And I think it's important for all the maps, but mainly for historical maps, because I think that for every historical maps we have to choose the right algorithm for that map, because there is the formation for the different grid and datum, as Gabor said, but also there is the formation of the paper on which the map was printed. So, for the geodetic datum, as expected Gabor, historically in Italy, local ellipsoid orientation were used. Till something like 3 months ago, when in Italy the geodetic datum was changed, and now we have a dynamic geodetic datum based on permanent GPS station. Before, we used local oriented ellipsoid. Orient locally an ellipsoid means that we choose the best position of the ellipsoid in that point to have the best fit between ellipsoid and geoid in that point. Here you can see the tower of Monte Mario, that is the geodetic point that was most used in Italy to orient ellipsoid. But it was not the only, because the geodetic situation of Italy, geodetic story of Italy, reflects the history of Italy. Italy has its unification only in 1861, when from a lot of pre-unification states, Italy was unified, and so every state before the unification had its own datum, and so the Istituto Geografico Militare has to unify the datum to have only one system in all Italy. But it was not a process in one step, but it was a process in more steps. So the first step was to convert from a lot of geodetic datum to 3 geodetic datum, one for the north, one for the center, and one for the south. And it reflects the division, the political division before the unification. So our map is referred to a geodetic datum that use the vessel ellipsoid oriented in Monte Mario, while, for example, in the same time for the northern part, the reference was Genoa. But we discovered that there is not only one orientation of vessel in Monte Mario. During the years, as Gabor explained for other places, there were different orientation, and also for the same reason, because the map were started by the Istituto Geografico Militare while the orientation was still not perfect. So they started to draw the maps, and after other measurements were made and were applied to the new map. We used this transformation. This transformation was very easy to apply to the area of Rome because it's very little. So we estimated that only a local roto translation has good results to transform these coordinates to modern coordinates. Then, after defining the datum transformation, we wanted to study how can georeference and rectify correctly the map. All the GIS software uses less square feet accommodation, less square feet method, because we use more than the point that strictly we need. For example, if we have an helmet transformation that is only a roto translation with a scale shift, we need only 2 points, but with only 2 points we don't know if we made an error and how much it is. So we use more than 2 points, and to use more than 2 points we need the less square feet method. But after this, all the commercial software, like for example ArcGIS, told you that the error on a single point is the same as the residual. It's not the same things, because I'm estimating a transformation on some points, and the residual is only how much the point is still far from the point that I used. But this is not what we are looking for. We are looking for accuracy, how much whatever point you want to look is different from the actual position. So another point that I didn't use to estimate the model, how much I can expect is far from its actual position. If I think that the residuals are the error as ArcGIS, for example, show I overestimate my accuracy, and obviously commercial software won't let you overestimate what you are doing. So, QGIS offers the possibility to use points to estimate the error on points that you don't use to calculate and estimate the model. We can call them checkpoints, and the point that we use to estimate the model, ground control point. They are called so in photogrammetry, for example. And this is very important because with QGIS we can really estimate the accuracy. With ArcGIS we cannot do this. Also, QGIS offers the possibility to have a linear transformation, a linear transformation, a projective, a polynomial from first order, and a scheme plate spline. All these features compared to something like 1 year ago, because the georeferencing plugin was deeply modified. In this moment, when all work well, I think that QGIS is one of the best software that's possible to use. And also, it gave the possibility to choose the sampling algorithm. Nearest neighbor, linear, cubic spline, and lines. So we can choose whatever we want. We performed a lot of tests. We'll report here only some, because it was the first time we worked on QGIS, and we wanted to understand if there is some general rule that we can apply to this series of maps and to other maps. We performed some tests observing how the residual on ground control points and the residuals on checkpoints change, changing the number of ground control points, increasing the number of ground control points. Because we expect that after a certain number of ground control points, the accuracy and the precision will find a stabilization. And this is important because if we understand that there is a number of ground control points after which we can be sure that all the precision and the accuracy are extracted, we can think that this is the number that we can use. This is very important if you have a series of maps like here, because if you have to georeference only an historic map, maybe you want to use 40 points, 50 points. But if you have 12 maps or 50 maps, 100 historic maps, and you have big work, you have to understand, you have to find a way to decide how much ground control point you need for every map. Here we show only the polynomial transformation. All we know how work polynomial transformation. It's very easy. There is a polynomial for the line of the image and a polynomial for the column of the image. The minimum required point for the first order is 3 points, for the second order is 6 points, and for the third order is 10 points. Then, here is reported our first test. With the second order polynomial, we inserted an increasing number of ground control points, and we observed the residual on ground control point that show the precision, and then the increasing of checkpoint, of residuals of checkpoint that show the accuracy. The behavior is very strange because after some points we see a stabilization, but at the end, when we have 28 points, there is a strange peak. Okay, the first things we thought when we saw this trend, we said, okay, we have a broke point, check if there is a broke point. But we repeated a lot of time these tests on different maps with different algorithms, with different points, and also changing the order of points. We haven't had this strange behavior. We can see also on third order polynomial, and we see that there is, this is on another map, and still there is these strange peaks that appear and disappear. Also, the very strange things is here that the peak is both on the ground control point and the checkpoint. This is very strange, because if there is a wrong point, I expect that one has a peak and the other go down. This is very, very strange. So for this, we repeated a lot of time all the tests, also with the second order polynomial. This is the same we said before, changing the order of point. Changing the order of point, I expect there is a peak in the beginning. Still there is a beginning in the end of the path with other points. So we think there is something wrong in the software, but we think. So, sorry for this table that is invisible. In the yellow part there is the first column is for ArcGIS, the second column is for QGIS, because we say, okay, second order and third order polynomial are the same. Yes, it is true that the less square feet I can give some different importance to ground control point, to coordinate of the ground control point, or to collimation, but the results has to be very similar. And this is not true, because we have with the same points, with the same number of points, with the same transformation, with the same file, we have results very, very different. So there is some mistake somewhere, and we want to study this more, also probably developing an external routine that estimates the less square feet to understand if there is a problem in QGIS or in ArcGIS or in both. We don't know. The results, anyway, for the first map is this. That is very interesting. This is Piazza Venezia in the real center of Rome, and there is a big coincidence. We are very happy because they are very near to the graphical error that is accepted for a modern map, that is 1 meter. Very near. It's not a meter, but we are very, very near. In the future, what we can conclude is that this new plugin of QGIS is very interesting, but we have to make more deep investigation because there is something that don't work perfectly. Probably we'll develop an external module, as I said. After this step, when we'll be sure to have choose the correct combination of point and algorithm, we'll have the accurate georeferenciation of these maps. Thank you for your